What we plan to do here is provide some information about how to work together in this country to improve the situation and the accomplishments of ITS. So in order to come to that, we will go through a brief introduction of a background of work that we have done at the University of Patras and how that has developed to the work that we did together here in PHAROS. And then based on that, how do we see that we could, again, provide some support or ideas for you to further develop ITS in this country. So let's look into, we begin with the official definition of what intelligent transportation systems are. And here it's important to remember that it is not a simple field, but it is a synthesis of other fields. So electronics, telecommunications, and control are important in the development of ITS. This means that professionals from different fields work together. So in fact, this from the very beginning tells everybody that this is going to be leading to sustainable results, because the different professionals are learning to work together from the beginning, which means that the result is going to take into account the different ideas and the different options and solutions that the different professions provide. We will be briefer in the other slides, but it was important to explain the definition. So the goal is to use our capacity and not spend too much money in capacity of the network, but use the capacity more efficiently to improve very substantially what we can do in mobility, safety, and productivity, and reduce the environmental cost of travel. What we will see here later, also in the discussion, some ideas about what we see as opportunities for what can be done here in Egypt, which essentially evolves around the use of both wired and wireless information and communication systems, both in terms of what can be done in the transport infrastructure, but also with respect to the vehicles, in order to improve safety, security, mobility, and reduce the energy and environmental footprint, but also increase the efficiency and productivity of the networks and fleets in the country, and in that way achieve a higher competitiveness of the national economy. So let's go into the background of some of the work that we have done here at the University of Patras that has prepared us to be able to work with you. First, we will look at an example from an application in safety and security, and lessons that we have learned from our work in different areas in Europe. You have alluded to an application in Athens. Very briefly, what we do is we install virtual detectors on the pavement, yes, and we're able to, even seconds before a crash, to identify that the crash is likely to occur. This is leading to a warning. The operator can, or personnel at the site, verify. Then an incident log verifies that indeed we have an incident. Then a quick simulation, by quick I mean in less than a second, selects a best response in real time. And then the best strategy is selected so to automatically implement and respond to that incident. Therefore, setting a signal to signs and also SMS. If necessary, personal assistance is allowed. And we check the incident to see if the road is cleared. Okay, we got a second example from work that we've done with other organizations in crisis management. Here, The problem is looking at the civil protection and using location intelligence for this in cases of disasters and crimes that are unpredictable and where a lot of locational information is available. So our objective is prevention and protection against a number of causes of crisis, and being prepared for what may happen in terms of assessing the risk, installing autonomous systems, educating and training rescue units, organizing and maintaining this capability. Also during a crisis event, coordinating response, supporting the authorities, and recovering after the event. The players in such instances are the volunteers, professionals, and civil protection teams. Of course, these are included, some examples are included: firefighting, rescue, emergency medical services, and so on. The location element is everywhere. We locate the high-risk locations, the locations that are safe for people to go in case of crisis, the critical networks that should maintain open, and the safe routes for people to follow if there is a need for evacuation, and the way that we should maintain the assets in view of a crisis. What kind of incidents are we considering? Hazardous material, terrorist attacks, natural disasters, multi-agency enforcement, and cases of multiple casualties, search and rescue, and even a failure of infrastructure. Some examples. Unfortunately, there are many examples, so okay. We take advantage of early warning systems from satellites, and thus being able to map the impact of these disasters. Using also different kinds of technology, such as thermal cameras. And essentially, it all comes down to taking advantage of localized intelligence that is available to us from satellites, and being able to automatically classify the data that come from the field in case of crisis. Such methods that we have developed are also available on mobile devices for ease of use and for being able to communicate between the members of a team during a crisis. Another example is in the area of freight transportation. And here the question is, assuming that we know the transportation companies in a region, and assuming that we know the storage services that could be used, then this is the place that we offer, is a place that brings together the two parties, that is, on the one side, the producer and shipper of a product, and on the other side, the carrier. And here the shipper indicates the route details, indicates the schedule, pickup and delivery, time window, packages to ship, and the carrier can see all the shipments that are available and need to be carried. Then the carrier makes a bid, a price, and the shipper receives a mail and selects a carrier and makes an action that is yes or no, and monitors the job, and both parties are obligated to finish the job. Okay, this is a typical form. Next example is road energy management. And here the objective is to reduce the fuel consumption and impact, especially during incidents and congestion, but while preserving safety, security, and reducing the environmental impact. We can do this using GPS and using either historical data or real-time data. In case of historical data, of course, this is the type of GPS data we get. We plan to use these data in order to get the velocity in the area of application. When we look at the data, then we can fit statistically the data and understand the properties of the data so that we can use these properties to make some decisions about how to respond to future needs of estimating velocity, travel time, and so on. In real time, of course, we can also do it by estimating the velocity and the energy consumption using the data that, for instance, come every 1 minute and re-estimating every 1 minute and using the older data. And using this information, we can provide the data to us, to anybody, through a database or a map. Okay. This is supported by different types of infrastructure in the field. One type is intelligent video with drag and drop detectors in the camera field so that we can support the data that come from GPS. Also from information from a radar. Radar can be in the field, and given a radar in the field, we can detect that there is an incident in real time. Typical radar installations. Another part of the package is the ability to read the license plate of individual vehicles in cases that we have areas that are to be secured. And this is a typical license plate reader. Using this program, we can provide safety and security alerts, congestion alerts, incident alerts, support fleet management, pollution alerts, provide greenest route estimation and energy consumption estimation. Another example is one for air pollution. Here we are particularly concerned about the particulates 10, which is, as we have seen in a study over the world, it is only very few cities are able to stay below the threshold that is defined by the United Nations. In fact, in a recent study, only Stockholm did that. Okay, so we are concerned, given the EU directive, we are concerned with particulate matter of different size and ranging from 10 micron to 1. It's important to see what is the cost of pollution per ton. What was the cost in 2002? 33,000 euros for the 2.5 particles, as an example. Okay, so a typical example from Patras indicates that we have increase in pollution in winter when airspeed drops and when there is a high traffic congestion in the morning. Okay. Okay, of course, because there is lack of data often, we use studies from different areas in the world. For instance, from Turkey, we have a contribution that indicates that distance-based emission rates will be different depending on the speed. Okay, so in addition to the pollution coming from land sources, when we're near the sea, we also have the contribution from sea transport sources. And most of these come from sea transport that originates from ships that come through this area and then, as you can see, go to Europe. A particularly severe incident in Patras, this is the main bridge, where we could not see across, was in June 2014, where dust dry deposition and dust wet deposition was very high during a particular 2-day period. And as a result of this dust coming to, this is the dry dust coming to Greece, we could not really see in a short distance in the city. Okay, so having seen these examples, we come to the applications in PHAROS, and here we have as an objective, as was very well explained earlier to you, to work with eco-routing in Greater Cairo. And this requires an integration of features that are already working in the ALTER fleet management system, and based on the new features, the intention is to bring in an innovation and further improve its capabilities. So what are some of the additional routing features that we introduce to this already working platform? One is being able to estimate travel time from the data in the field, and another one important is a fuel consumption estimation. Some other also were listed before. Another aspect in PHAROS is being able to evaluate the driver and the routing decisions. Reports are produced. The reports incorporate the fuel consumption and emission, and then a decision support system looks at the reports, the evaluation reports, to achieve eco-driving. In addition to this, we have a method to allow the model to learn so that it does not stop working when the data are changing. In fact, it uses the new data in order to learn that we have some changes, so it is able to make short-term predictions and improve the accuracy of the whole process. So having seen this background, what can we do? What can we say about the future? Some ideas of ITS in Egypt. We begin with a thought that everything is based and will have to be based on enhancing the existing policies in the country. So there is a need to use effectively a national strategy for intelligent transportation systems, and based on that strategy, which indicates what do we really want to do in the next, for instance, 10 or 15 or 20 years, then we should also be able to have an architecture that is the basis for our future work. The architecture should not be binding in the details, but it should be binding in the important basic matters, and it should be a result of consensus between the different policy players in the country. We should agree on what should be the basic services that should be provided in the country, and we should also consider how we can take advantage of our strengths in the country in order to work together with other countries that perhaps we think are more advanced, but in fact they could develop much more if they had the cooperation of a country and a population and a capacity such as Egypt. Okay, having talked about these thoughts on policy, then we should also look at organizational agreements. As we remember from the first slide, ITS is a synthesis of fields. So here we come together to this thought. We come again, and we have to understand that there has to be communication within an organization, because within an organization there will be different specializations, as we had initially indicated, electronics, communications, and so on. Also between organizations. There has to be adequate personnel and logistic support, and that support can be in terms of what is provided by the government, but also we should not expect everything from the government. We should strengthen the organization of ITS that involves private enterprise in the country, which is also already quite strong. And we should indicate that freight is a very important lever in the economy, so we should be able to plan for the equipment storage and sites that are necessary for further developing freight nationally and internationally, because Egypt is in the center of freight transportation in the whole world, as we all know. Okay, so having talked about some policy and organizational thoughts, then we come to some ideas about systemic enhancements that could form the basis for future development. So one is the need for a command, control, and communication system that is specifically focusing on energy. But not in theory, but in practice. Another one that is also systemic is the need to support eco-friendly fleet management. And there I should, of course, I don't need to remind that PHAROS is in the middle of this aspect. And a third one, also systemic, is to be able to provide a system that educates, trains, supports the drivers. Because if the driver cannot drive in a green matter, then anything that we do will not be successful. Okay, so there are also some more involved and specific applications that we could talk about, and are probably the most important ones, but I'm sure that a lot of you will have in mind some others that are also very important, but for lack of time and space, let's talk about these. Applications for emergency situations. This is always on top of a list. So this is where ITS can in fact save lives, save money, and actually improve the economy. Very close to that is the ability to avoid a large number of accidents. And of course, the most important accidents are the ones that should be taken care of first. But in general, reduction of accidents means a substantial improvement in the economy, because the cost of each accident is very high, and the cost of serious accidents is even higher. Another application is the ability of the people now, not freight, but the people, to make trips that are environmentally sensitive, and that requires a lot of work. And one aspect that we should not forget is that everything that we have discussed until now is based on a lot of information. Being able to have a lot of information, collect that information and store that information. That by itself is a very important task, and in fact, in Warsaw, where you mentioned earlier, our occasion for talking about PHAROS, there was an interest in collaboration in terms of how do we work together if we have lots of data. This is a problem. Okay, so just to finish, of course, everything is interconnected, so if we're able to move from where we are now to where we're going to be in the future, which is, the future is the point where cars talk to each other to indicate that there's danger, or cars talk to pedestrians or to bicycles and so on. There will be a hybrid situation. So it's important to take care of what happens between now and our final result, our final point, the point of destination, which maybe is 20 years from now. In this period, our world will be hybrid. So Cairo will be full of hybrid systems, meaning some of them are going to become automated while others not. So there, that is a unique situation for the private sector to get involved in order to support this change. And the change will happen over a 20-year period, so it is enough for the private sector to plan. So with these applications, we can then enumerate some of the potential benefits from these thoughts, these programs, these changes. We expect that there will be an increase in safety, security, reducing the congestion and delays, thus the cost, reducing pollution, and improving the competitiveness of the national economy, but also the quality of life in Egypt. And thank you for your attention.
Thank you very much, Professor Stephanedes. Maybe we can give a couple of minutes if anybody would like to make any questions before we move on. Yes, Noor. And if anyone will ask a question, please introduce yourself and speak slowly for the translation as well. If there were.
Good morning, my name is Noor Shawi and I'm with Softec International, the industrial partner in this project. And I have a question about the crisis management. Has this been anywhere rolled out on a national level, or is it only so far just on a POC or a prototyping stage?
Okay.
Is it actually being used by governments to handle
the question is if what we discussed here for the example of crisis management, if that has been applied already in a country-wide application, or is it just theoretical? In fact, it is something in between. In other words, it is definitely not just theoretical. It has been applied, but not country-wide. In fact, the reason that it cannot be applied country-wide in Greece, for instance, is policy-related and organization-related, as you would expect. And we are working with smaller units of government that are applying this method. And from smaller units, we expect that we will go to regions that have also indicated their interest for different types of disasters that thankfully are not yet very big, but relate what you would expect: the fires, the water in the city, floods in the city, with or very high temperatures for specific groups of population. Each different type of crisis has its own characteristics.
And as an academic institution, you can cooperate with industry to take this into the commercial application, which would be used by governments to handle first response in crisis. Is that possible?
Yeah, that would be the next step. For now, the tools that we are using have all been developed in the universities of the country. But they have been applied in specific cases of forest fires and flooding. And based on the observations of the results, we're able to further improve on these. And in fact, this is finding its way to become a product or a family of products. But there, of course, it would be nice to have cooperation across countries. You have a company, you are successful. Maybe you can look at it and maybe you can have some cooperation.